In this demo, we will be looking at model signing as a way to defend against certain type of attacks. The attack used in this demo would be wrapping around having a malicious wrapper which extract data or as a thread while developers are like loading the model and sort of using it. So this is a quick overview of the README, what we're demonstrating, the problems we're trying to solve, and what this demo will show. A bit of the attack where the wrapper silently steals data, and the defense where we use a certificate-based signing to block unauthorized model and prevent data theft. So all this will be in the description. Let's quickly get to the demo itself. Now, for the demo, this is it. I've set up the virtual environment and requirements. I've installed the requirements into the virtual environment, and I will just run the demo file itself. A couple of things to be expected is the basic setting up of things. One is the certificate and the model. We are using BET, the straightforward BET, because it's easy, and this is currently on a local machine, very little resources. So setting up the certificates and model that has been set, you see them show here in the model and in the stats file. So now once that is done, next thing will be to see the attack demo to see what happens if we are trying to attack a model that's not been signed. So what we see is the model gets loaded and it processes some documents. After those documents has been processed, we also log out how data was stolen while the model was actually doing some activities. And this were happening silently, and this is being logged to a certain file in the logs file. So the wrapper runs silently while the model is being used normally. So that shows that, okay, we can actually extract data from models with some malicious libraries or some stuff around that. Now, the next thing will be to see how do we defend against that signing legitimate model, found model, signed model. So now we have like the two types of model. We have the one that has been compromised, not really compromised, but the one that we use to demonstrate the attack. And we have a legitimate one where it has been signed. Now, to show the defense, we will just press enter. Now, once we press enter, you'd see one thing, it's clear and it loads the actual proper one. Then once it does that, it attempts to load. The first thing would be to load the unsigned one to see if it worked. Now we see that without any security enabled or without any form of defense enabled for the malicious wrapper was able to bypass security. Now, once we enable secure loading mode, it ensures that any unsigned local models will be blocked. So we attempt to load the unsigned one, which is the backdoored one again. That's the one without any form of signatures. What happens is it gets blocked. It says unsigned model detected, which is this one. Loading unsigned model is prohibited for security. Please use this. Now, the next thing will be to load the actual signed one. And two things happen to load the signed one. We load it and we verify that the signature or whatever form of signature is there is what it says it is. So once we load that, a bit of logging out of some details, then you would see that it was able to do two things. It was able to verify the hash, the file hash, which was the signed version of the safe tensors, which has the weight. And the second thing, it was able to verify the signature, which is just the manifest file being signed, which it gets the public key and does some kind of validation against the private key that was signed by the developer to generate the model.safetensors.sig. So once that is done, the loaded file the secure model was able to be loaded correctly. The verification was correctly verified and it was able to load the verified model. And it gave some details. Testing signed model functionality works fine and no data was being stolen because this was properly signed and there wasn't any wrapper underneath that could bypass that. So this shows that this is one way just to prevent like some. Currently, we do load models, and this is just one way to show an interesting way of how model signing can be helpful and help with some certain level of security. Definitely, this changes the threat model or the risk involved as different things can happen when a CA get attacked. How are we going to handle it? Or when they find other ways into actually finding ways to steal like private keys, or where the private keys of the developer are compromised. But this is one fun way to see. And something. So what happened, why this is realistic, and how model signing helps legitimate model weights, not tampered with, the malicious code, and some other things. So why is this realistic? Attackers can compromise this. Model files themselves appear legitimate, and how this helps. Model signing is an interesting thing because it enforces trusted loading, it prevents unauthorized inference, and it maintains a chain of custody. And there's also like a public record of the different things that have happened on that model. So going back to the README for just some things is, if you check, these are some of the implementation context, and one fun part is the risk, the trust model risk, and in case this is compromised, the adoption trade-off. Yes, something would be security definitely sometimes can slow down wide adoption. There's also like, it might be good to have, but is it the right time to have it? Real world adoption drivers in some industries where the stakes are very high, this can be super important to put, especially in areas that has to do with life, like healthcare, finance, and all those things. And some mitigation approach. So once you enable or put a form of defense pattern, it means you also kind of shift the attack flow, or the risk, or you open up to a new kind of threat model or security model, or a way of form of attacking. So that is pretty much it for this demo. So some of the mitigation approach to, since we now use CA and CA can be compromised, how do we do that? Certificate transparency, hardware security models, and multi-CA validation for redundancy. So that's pretty it for this demo.